you by thesis123.com. I learn and teach online.
Here's the next question, number 11. Consider a one-turn rectangular loop of wire placed in a uniform magnetic field as shown in the figure. The plane of the loop is perpendicular to the field lines. The resistance of the loop is 0.4 ohms and its inductance is negligible. The magnetic flux density is a function of time and is given by B of t is equal to 0.25 sine omega t, where omega is 2 pi into 50 radians per second. The power absorbed by the loop from the magnetic field is dash. Okay, so first we begin by writing down what's given to us. We have here the area of the rectangular loop. The measurements given are 10 centimeters by 5 centimeters. So that's 10 centimeters by 5, which is 50 centimeters square. Now it is important to note the units. So we have to write area in terms of meters. So we convert this 50 centimeters square and we write it as 50 into 10 power minus 4 meter square. And we have been given the flux density, the magnetic flux density and resistance. So this is all that's been given to us. Now to solve it, we need to find the power absorbed, which can be denoted by the average power. So power average equals integral 0 to t v square by r. Now this is the average power and this v here is Vrms, and the RMS voltage can be found by using the equation minus d phi by dt, where phi is the flux. Now we don't have flux either. What we have been given is the magnetic flux density. So we can write this as minus d by dt of magnetic flux density into area. Now flux is density times area. So this is V. Now let's substitute. We'll find out what V is first in order to plug it into the power equation. So we have V is equal to minus d by dt of B. So B is an expression. We have it in terms of 0.25 sine omega t into area. So area is 50 into 10 power minus 4. Now we need to differentiate this entire expression. So before we do that, let's write down what omega is to. So that's minus d by dt. We have been given what omega is, right? Omega is 2 pi into 50. So that's 0.25 sine of 2 pi into 50 t into 50 into 10 power minus 4. Now if we differentiate this, we get minus 0.25, let's take all the constants out, minus 0.25 into 50 into 10 power minus 4 into, now the differentiation of sine is cos, so cos of omega t into omega. So that's 2 pi into 50 into cos of omega t. I'm going to write cos of omega t as omega. I'm not going to substitute the value of omega there because we will have to find out the average power. So I'll leave that as it is. Now if we solve this further, we can write this as, now I'm going to write the entire thing in terms of a fraction rather than a decimal point to make it a little easier. So we have 1 divided by 800 times 100 pi cos of omega t. So this is V. Now we need V square. So V square term becomes 100 pi by 800 whole square into cos square omega t. Now cos square omega t must be written in terms of cos. Now we need to remove the square term and recall from our trigonometric relations and equations what cos square theta is. So we can write this as v square is equal to 100 pi divided by 800 whole square into, now cos square theta can be written as 1 plus cos 2 theta divided by 2. So 1 plus cos 2 omega t divided by 2 is what we have now. This is v square. Now the power equation, power average, is integral of 0 to t v square by r. Now I'm going to plug in this entire expression in terms of v here. So let's write the constants out. So that's 100 pi by 800 whole square, 1 by 0.4, that's r, integral of 0 to 2 t. So 0 to t. Okay, so we have 2 here, which is also a constant. So we'll put that down here as well. 1 plus cos 2 omega t. Now this entire part will result in another trigonometric form, a trigonometric relation. So to find the power of average, we work on the constants alone. We ignore this, we work on the constants alone. So the power now is pi square by 64 into 1 divided by 0.4 into 2, which gives us a value of 0.193 watts. So this is the final answer here. We'll note that down. That's 0.193. So that's the solution, and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.